law of the theory was all atoms of a given element are identical. So all atoms are first identical. Let us break it. Now you have sodium. These atoms of sodium that you took here from the powder of sodium, your atoms of sodium. So let's say you have 20 atoms of sodium. All of these 20 atoms of sodium will be firstly identical. That is the first thing. They will be identical. They'll have the same size. So you have sodium atom number 1 and sodium atom number 2. All of these will have the same size. All of them will have, let me write this properly here so that it is legible, the same size. All of them, they'll have sodium atom number 1 and atom number 2, they'll have the same size. Point number 2. Point number 3, they will have the same mass. So the mass of sodium 1 and sodium 2 will be the same, and also the mass of sodium 3 and sodium 4 and so on. All of these will have the same mass. So the content of each element, of each atom of these elements will be the same. And lastly, they'll have the same chemical properties. So, for example, if this sodium atom number 1, let's say it melts at 200 degrees Celsius, then the same property will be for sodium atom number 2. The same will be for sodium atom number 2. They will all melt at 200 degrees Celsius. And atoms do not melt, but if they were to melt, then they will all melt at the same temperature. So they'll have the same chemical properties. Lastly, the atoms of one element are different from the atoms of another element. So if you have atoms of sodium on one side, they will not equal atoms of aluminium on the other side. These atoms here will be different. How are they different? They are different in size, they are different in mass, and they are different in chemical properties. This is one of the very important laws in the Dalton's atomic theory. It really helped to enhance the study of atoms and elements, just stating that atoms of sodium are not the same as the atoms of aluminium. Now moving on to the third law, but before we go to that, a simple analogy that you can use here is, especially for being identical or having the same size and mass and chemical properties, we always do in computers, we copy and we paste. So you can think of it as the same way. When you copy content, a certain text, when you copy content, a certain text, let's say A is big. Just write that nicely. A is big. This, when you copy this and you paste it, it will paste the same thing. A is big. So these spaces here will be the same. A will be capital and big will be written as big. So you have copy and paste. So this is the same. When you have sodium atom number 1, it will be exactly identical with sodium atom number 2. That will be exactly the same. But if you are to copy, if this text here was A is big, then let's clean this up. For the analogy of sodium and aluminium, it is the same as saying here A is big will not be equal to B is big, because we have a change here. Here we have A and here we have B. That is one of the simple analogies that you can use to differentiate between atoms of different elements. They are not the same. They are not the same. Okay, now let us move on to the third law. The third law, it says that compounds of atoms of more than one element. Compounds are composed of atoms of more than one element. So we can define here a compound has atoms of more than one element. So we have a very simple compound here, sodium chloride. So this is an atom of sodium, and this is an atom of chloride. Chlorine. So we have these two different atoms. So sodium chloride. Very simple. And in any compound, the ratio of the number of atoms of any two of the elements present is either an integer or a simple fraction. Now here, key. The keywords are ratio of the number of atoms has to be an integer or a simple fraction. So what is a ratio? So firstly, a ratio is a division between two numbers, A over B. So for example here, the ratio of sodium chloride for sodium over chloride is, there is 1 sodium divided by 1 chloride, so we get only one whole number, which is what you call this an integer, a whole number. So integers here are 1, 2, 3, 4, 5, 6, and so on. So you can have a ratio of 2 to 1, 3 to 7, and so on and so forth. As long as we will get there will be 3 to 7, 2 to 1, this is 3 to 1. These ones, they will always give us an integer 3, and here we get an integer of 2. So we can have these ratios. Another thing is, it can only be a simple fraction. Now, what is a simple fraction? A simple fraction is a fraction whereby A over B, this is an integer, and this is also an integer, not a decimal place. So here you can have ratios whereby your compound sodium, there are 3 sodiums and chlorine, or just find a different compound. So the compound can be here, hydroxide. So you have 3 chlorines, and how many no, this is not an element, something simple. Okay, let's get back to chlorine. It is simpler this way. So we have sodium, 3 of them, chlorine, 2 of them. So this is possible. It will form a what? The ratio 3 to 2 will form a simple fraction of 3 over 2. So it is allowed in this law that the compounds, the ratio of the number of atoms of any two of the elements present is either an integer or a simple fraction. Or here we can have even a better representation from calcium chloride, which has a fraction. We have calcium chloride. So you have 1 calcium and 2 chlorides. So the ratio here is 1 to 2, which is equal to half. So this one here is a simple fraction. Same can be 1 over 3, or 2 over 5, or 7 over 8, and so on, as long as they're simple fractions. What you cannot have as a ratio, and this will even be used in empirical formulas from Dalton's atomic theory, is that you cannot have here 1 with a ratio of 1.389. See, this is not possible in Dalton's atomic theory. Next,